Hi, my name is Precious, and today I'll be taking you through your projects for your secured A. So I'll be sharing my screen shortly. So sit back and relax. So here goes. So what's our topic? Our topic is enhancing Igbo named entity recognition with XLMR. XLMR is a transformer-based model. So it actually XLM for better. Peace. We'll be snappy about it. I know you already have a lot to read, so I don't want to add more things to bore you. We'll just be looking at technical things or some things that the most likely you have to cover. Most likely. Okay, most likely you have to cover in your defense. So you have to have an idea, pay special attention when you're reading to these areas I'll be talking about, okay? So here goes. Chapter 1. The background. What is the background of our study? What is important? So African languages like Igbo are actually low resource for NLP tasks. What's low resource? Meaning that there are not enough documentation, or there are not enough data sets corpora for NLP. What is NER in the first place? NER is an application or is a base task in NLP. Natural language processing is NLP. NER, named entity recognition. So it identifies and it labels entities like names of people, places, organization, dates, and events in text. So when you have like millions and billions of text, hope you know that social media, which generates billions of text, reshares, retweets, tweets, posts, which generates lots of data. So NER is what we use or what is used in such domains to actually extract, see when they want to focus on significant things like people, place, names of people, names of places, names of organization, names of date. They even use NER in recommender systems. For example, your Netflix, maybe Netflix and Google usually collaborate with all these applications. So maybe from Google will find out that using their NER or NLP, you'll see discover the most searched name or the most searched movie name in Nigeria at the moment is King of Boys. No, let's use the most recent one. How to kill a monkey. To kill a monkey. So NER will dictate, okay, monkey as a name of an animal or a name of a person. Like it will dictate. Then what to do now do? For it will now collaborate with Netflix and then start recommending anybody that searched for monkey or search for kill. When they come to Netflix, they are seeing to kill a monkey as recommendation of a movie that they want to watch. Do you understand? So NER is a basic task, it's a basic task in NLP for language assistance, for chatbot, intelligent search, etc. So there are a lot of progress that have really gone into NER for English, French, and Chinese, but there is this wide issue, wide gap in African languages like Igbo. And we can see how many times have we heard of a chat GBT for Igbo or a get because of these issues of NER Igbo language. So what's actually causing those issues? We have limited data sets, limited standardized corpora. It's a it's a data set or a data warehouse that contains lots of data, lots of text, sentences, phrases, dialects like um, variations of Igbo or variations of languages are contained in a corpora. Those are used to train a model to understand the intricacies of that particular language. So these are the just read through. Then we just move quickly to the statement of the problem. So although much improvement has been achieved in natural language processing tasks, the development of NER, that is named entity recognition systems for Igbo languages, that have seen very not explored much. Although a lot of some research has started to be done. We have some research by Igbo NER, we have Igbo bets, we have some application research already, but they are still being constrained by the amount of data set and the amount of entity types. Okay. So what is the aim of the aims and the objective of, I have to make some corrections. It says four entity types. To examine existing transformer-based models and how well they handle Igbo NER attacks. To expand Igbo NER corpora, we will achieve number one by literature review. To expand our Igbo corpora by adding more entire sentences with just four entity types, fine-tune XML model on the new dataset. So this model is a multilingual transformer-based model. But now we are going to be using our Igbo dataset to actually make this multilingual model to learn Igbo, and we use it. Okay. Then after that, we evaluate the fine-tuned XML model with precision recall F1 score. Then after that, we'll connect our model to a web interface so that we can be able to predict. Okay. Still loading. But okay. We'll see that in a while, in a short while. So limitations of study, I said the dataset issue, okay, and other issues. So just read through. Literature review. Now, literature review, we will not know about the limitations, we will not know about the problems, we will not know about what people have done, we will not know what we are going to do if we don't do a literature review. What is literature review? Literature review is analyzing and looking at the existing work that have been done around the areas of that thing that you want to do. So from a literature review, after you do it, after conducting a literature review, you now find, okay, this is the problem and how that want to improve on it. Do you understand? So that's why literature reviews are very important. So make sure that you go through this that very well and read through the literature review. When you read through the literature review, you will now understand why this study, this research, this project is not important at this time. So there's a lot, we have to read them. You can see that for each of the issues, we also looked at the limitations they had, and then we now said, okay, they are going to solve some of these issues. So I'm going through the literature review. There's quite a lot. I spent extensive time in the literature review. Then we are now going to move straight to methodology. We follow the practical and experimental methodology for this study. And what was our research design? We had three stages in our research design. We have our dataset development, where we used an existing dataset from Igbo bets, Igbo NER. It's an Igbo NER dataset. We used and then we improved on it. That was the dataset that we used. Then after that, we processed the data set. Let me show you some things in our code, and I hope you get an idea of it. I get the hang of it. So in this first code, we made the notebook to know which folder our files where we're going to be working. Then here we did some adjustments. Here we're trying to know how this is how the our data set about the CSV file looks like. So you have a token, you have the label, we have a sentence ID. Sentence ID, you can say that this is the first sentence. So here's sentence ID one, here and stuff like that. This is where we did lots of now in this code we are converting so this model XLM Roberta based model, we use this .json files. It's just JSON that it uses, not it does not use .csv. So we have to now to convert it to a .json file. So here also now we're now trying to show an example of how the a sentence now will look like in JSON file. And this is what we have. Yeah. Then, okay, this was the type of processing I've been talking about that. So just read through. These are some of the things we handled in our code. I don't want this video to be too long and too technical. So we now go to our existing system. What's your existing? Out of that you picked up, which of the system are we going to improve on? We now see that this Igbo NER dataset is oh my god, I'm sorry. What happened, guys? Oh, are we? Okay. Is a publicly available dataset for NER in Igbo language. Just read through. This is what the system is. What was the challenge? Actually, we have some issues in the trick size, some of this, or the comedy, and then the data was so that we increase the data sets, right? So this is the architecture data set. This is an Igbo text corpus, so whatever. This is what a corpora is like. This one, this is not just this or this. I just shoot for just 15 lines. You could it's as much as 10,000 rows and more and above. Then the annotation process, the process of like working on the stuff and converting it to this is what they used. They after they got all their sentences and everything in the Igbo text opera, they annotated it by using BIO tagging, beginning, inside and outside. Then they moved and created this Igbo dataset, which they now fed into this model that they fine-tuned. Here's the model that they created. So what are we proposing in our own system? We are proposing that instead of using we're going to be using XLMR model. Why are we using XLMR model? When you go to Hugging Face, XLMR model it has been used by billions of people for many languages, and they perform well in those local low resource languages. So that we are using it. We're just fine-tuning it. Fine-tuning it in the sense that we are taking our Igbo data set and we are training this model to understand Igbo and training it to know how to do tax in Igbo. So that is what we are proposing for our system or the database, and not just that for our new system. Other than also creating a simple web interface so it's that we can use to instead of going excuse me, instead of going into the code, sorry, instead of going into the code to start but for a non-technical IC person, you can just come to the web interface. That's something cute and beautiful can come from this, but at the back end there's a model that was created. So these are the architecture of our proposed system. Have a data layer. There's data set and the processing layer. Then you have the model layer where the model was fine-tuned, and then you have the application layer, the web interface. So this is fine-tuned SNMR model and then our web interface. What are the benefits? The system fixed the trick problem. Okay. Not totally, but to a great extent. Because it will have different dialects, different like if you go to what is this place called not Ohaje. No, there's this place the boy they're from dialects in Igbo. If you speak Igbo, you don't even know that it's Igbo. So these are the benefits of the proposed system. System dataset schema and structure. So in our dataset we divided it into when you divide one thing into three, we now use two parts for training and then use one part for testing. Okay. So these what I said I use this how the tokens, the label. Yes. This was manually annotated by the way. It was manually annotated. And that this was really stressful to create the data set. The data set was a different work on its own, but let us not go into that. This was manually done. All these thousands of rules were manually annotated. Like you have to use your hand because what you want when you now feed the system, the model with this, it will now learn based on what you've taught it. You will not teach the model nonsense now. You have to do it the correct and the right way. Mhm. Then in our this thing, we do not dispose of punctuation marks, right? So for our chapter 4, we have our system design and implementation. How was the system designed? How did everything go? So for information, the main programming language used was Python. Hugging Face Transformers was utilized to load our XML model. Not just that, after we fine-tuned our model, we went ahead to upload our own model to Hugging Face. So when you want us to use the Hugging Face model from Transformers library, this is what you just do. You just copy this link, simple, and impute it. And that's what we use. This is what we actually use on our app. Let's connect our model to the app. Okay. Pandas, NumPy, this is NumPy, sorry. NumPy. They're used for same data cleaning and data manipulation. So we used Google Colab. We use Google Colab. So Google Colab is a web version, but you know it's web. Like Google Colab now, it's a Google and Jupyter notebook virtual environments. Okay. So because the system I have is a low model, like the system not really optimized for training of models. I decided to run the code, or we are running the code on Google Colab. So Google Colab environment. Google Colab environments, these are the specifications for it. So read through please. So for our model configuration, when we are creating our model, when we are training our model, these are the configurations, some of the configurations that we use. Oh, let me show you. It is in the code. When we are setting up our trainer. So trainer is an API. When we are setting it up, before we do this trainer.train, you will set up your arguments. So you do some testing and trials, you know what will really suit your system and give you the best results. So we have how many epochs we used and all. So this is it. So after this, we now had our we trained our model, and then please after training our model, we saved our model and we uploaded it to Hugging Face Transformers. So when we now come to the result and discussion, after the training, we saw the performance. So this table shows us the performance of our model: precision, accuracy, recall, F1, and accuracy. Okay, I'm meant to try this is not. This is a local code. I actually would have showed it on Google Colab. So I might share the link to Google Colab. These are the code run. This is not the result, please. Let's just take but for the purpose of this showing this work. Let us stick with that for now. Okay. So at the end of the training to will show you a table like this. Okay. But payment this table is not correct for this work. So from the results, we saw loss trends, what happened. The training and validation loss dropped steadily across epochs, meaning that the model generalized well without overfitting. You can see it in our code. You can see it in the curve that we are seeing here. At the beginning of the training, loss was really on the high side, but as time went on, it moved to as low as 0.1, 0.2. Okay. Then this is the evaluation metrics over epochs to see how well or how they performed. Okay. So this is a balanced result shows that show a balanced model that continues to improve and should perform well in recognizing entities in text. Then we move on to our sample visualization. So This is our app. So we said we copied and pasted the text here, and then we click analyze to show you. Now here's this the beauty of this work. It would show you these words or the subwords and put their named entities that you recognize in brackets beside them. So and then you use colors tags before you can able to see clearly. All organizations are in green, locations are in blue, and then person are in pink, right? Pinkish King Kong. Yeah. Outside, these ones ash. For sentences that we not know, they're not in person, they're not in location, they're not in organization. We just use outside. So that I have much outside. Oh. So we in our app we have a sample statement. Chika be aware now for 2020. So let us analyze that. So this is it. It's a Chika. So now we still have this issue of normally transformer models they know how they like breaking words like based on their stuff training issues because they maybe in the course of training they have seen there's a word like ka ek ka in Igbo, so it's splitting it. But if you check chika chi and chika, they are both person, you recognize them as person, but it's trying to tell you that chi is the beginning of a person and this car is the inside of a person. Yeah, so chika is person. Biara. So and see the dates, it's recognized dates, you recognize alpha dates. So these are the prediction. After showing it in color, it will also go ahead to show it to you in a table. All right. Oh, we are here. Let's get it here. So we faced some limitations. Was confusion around diatrics, like so you got these recom issues. We had issues tell and then even with the graphic version. So some of these issues of data, these issues came from the quality of the data sets. So we can do a further work by um, adding more Igbo linguistics to increase our Igbo corpora, and then they will do the manual annotation since they're in a better position and in best position to do that. Right. So in conclusion, these are the summary of our findings, read them, conclusion of findings, and the recommendation. So I hope I was also showing you, okay, I've shown you the app, how the app works, I've showed you where the login, where the model can be found and how it can be used. Then the app, please, I shared you the repository on GitHub. You will see the app there, the app.py. It's a Python app. You see on there, you see there. These are the references. I just at the end of appendix at the appendix A, I just added snippets of the app to the work. So here you import what you're going to be using. Then you also import from transformers. Remember that to call our model, we have to use transformers library. So these are see what we use. Say we're calling our model to be used by app. Then these are some of the settings we have to do on our app to bring all those beautiful colors that you saw and all. Okay. Then for the model, I just selected some important parts of all the parts of the code are important, but to make this not be too cumbersome, these are some of the trainings. So I start from training training of the model. So here you go. And I also added data sets for you to see and have an idea of how it is. So that's all guys for today. If you have any questions, please make sure that you send it across by comment or via DM. I wish you success in your test, in your defense. I wish you success in your work. And I hope you get free and I hope you'll get your peace. Yeah.